Hi, this is part 2 of the series where we will create this animation using animation nodes in Blender 2.8. If you haven't already, you might want to check out the first video in this series. The link is in the description. Before we start, in the last video I said that Blender crashes during animation rendering with animation nodes auto execution switched on, which is still true at the moment, but one of my subscribers sent me a link to a workaround which I will show you at the end of this video for rendering out the animation with auto execution on. Let's get right in. Here I am in Blender 2.8. This is still beta. First, I'm gonna delete everything. And just like in the last video, for animation nodes, we are going to need some sort of base object that we can use to then duplicate or replicate with animation nodes. So for the sparks, I'm going to add a curve, Bezier. And in edit mode, we can see that we have two control points here. I'm actually going to select this one, hit V and say automatic. Now I have a straight line. And now I select all of them, hit W, subdivide, open this menu here and subdivide 20 times. So now my curve here has 21 or 22 control points, and we're going to need those or use those to deform this curve randomly and make it look like a single spark or lightning. This is done. This is our base object. Now I'm going to split the window, go to animation nodes, create a new node tree, T, open the tool shelf, auto execution on, always off, and switch on these three options. And now, oh, wait a second. So just to explain this a little, let me put the cursor here. I'm going to create a circle here. And in edit mode, I'm going to shift a Bezier curve. So I just want to show you here that this demo object here is one object, but it contains two curves. And those curves are called splines in animation nodes. So we have this one and we have that one. And the fact that one object, one curve object, can have many curves in it is exactly what I'm going to use here for creating those sparks. So Shift C to put everything back to the center. And now in the animation node tree, I hit Shift A, spline, and I'm going to replicate a spline, the spline that is here. That's actually not really visible. Let me make it visible first. So I'm going to set the fill mode to full and bevel it a little so we can see the curve that we have here. Now I hit the eyedropper because this is the spline that I will replicate. And this node here outputs spline information. So there's a big difference. The object instancer we used in the last video outputs objects, like these sorts of objects here. But this node only outputs spline data. And in order to put those splines that we're creating here into an object, we need a spline object output. Now I could create a new object here and then put those splines into that object, or I simply hit the plus here and animation nodes creates a curve object for me, calls it target, puts it in here, and now I plug the splines into this output and switch this on. Also switch on these two options, and now I need to tell this node how many and where I want to replicate this single spline to. And this node uses transformations, which is an input of matrices. We know that every object has a location, a rotation, and a scale, and one matrix in animation nodes. Just combines location, rotation, and scale into one data type. Now we can create a distribute matrix node, set it to linear. Let's make 10 new matrices, set the size to 0, which just means that we're not changing the size, and plug this in here. And now we have 10 splines coming out here, going into this object. And if I turn this up, we can see, so this one in the middle here, this is our original, and out here we have 10 splines. They're all at the same location, same rotation, same size. That's why it looks like 1, but it's actually 10. Next thing we have to do is, we know that we have all those control points here along the spline, and we're gonna move them around randomly to make it look like this spark or lightning. And for that, we are going to use an animation node loop. A loop in animation nodes consists of 3 special nodes. So first, we create a new subprogram, loop. This is our loop input node. So down here, we will be creating our subprogram that gets executed for every single spline that we have. Now what we have here is a list of splines that we want to plug into this loop. So we create a new iterator, spline list, and now we can shift a subprogram invoke my loop. Let me just give this a name, make sparks. Okay, and we can plug this in here. So the list of splines now goes into this subprogram. This node executes our subprogram, which we will be creating down here, once for every spline. So the output here is not a list anymore, it's a single spline. Whatever we want to do to a single spline, we can create here. And then this loop has an output, which is again a spline list over here. So if I just connect this up and plug this in here, now we're piping our 10 splines through our loop. Right, we still have those 10 splines all in the same spot, and our loop isn't doing anything yet. And in between here, we're going to create our subprogram, our loop, which manipulates a single spline to look like a single spark. And this node is going to call this subprogram 10 times and make 10 sparks. Now, how do we manipulate this spline to look like a spark? First off, this is one spline, and we actually want to move around each of those control points. And to get access to those control points, we need a spline info node. And the output here is a list of points. And to create a spline out of a list of points again, animation nodes automatically inserted a spline from points node. So we still have 10 straight lines and not doing anything really yet. But now we have a list of points, which is a list of vectors. We can add a viewer node, plug that in here, and here we see that we have 22 vectors, and each vector is one of those control points that we created before by subdividing our Bezier curve. Now we can do something with those 20 points. I'm going to need some space in between here. First off, we're going to move each point around with a vector noise node. And animation nodes comes with so many different nodes that not all of them are even in these menus here. And the vector noise node is not here. So we can go Control A, which opens a search dialog for animation nodes. And insert the vector noise. Vector noise. Okay. So I plug this in here, and we can see that this vector noise node takes in a list of vectors, but outputs a list of values, not vectors. That just means that we have to take our list of vectors and rip them apart into their x, y, and z components with a separate vector node. And then back here combine them again. And what we want to do is we just simply keep the x value, because the x value is going along our curve. All we want to randomize are the y and the z values. So this value is going to be the y, and then I duplicate this node, and this is going to be the z. I'm going to set the frequency to 1 on both nodes. And now here we have a list of vectors again we can use to create our splines. And we already get sort of a sparky lightning thing. Now we can play with the amplitude, which is, sort of the strength. We can play with the frequency, which gives us more or less detail in our noise. And it looks like this. It still looks like we only have 1, but we actually have 10. They're just all in the same location. How can we randomize that? Well, this loop input node comes with an index. So the first spline coming out here from this loop execution node here, first spline is going to have index 0. The second spline is going to have index 1, and so on and so forth. So we can use this index as a seed value for both of these nodes. And now each of those 10 splines gets a different random vector noise. And now we can see that we have 10 different splines. Can always play with these settings here. Amplitude, frequency. For example, take up the amplitude on the C a little. Okay. Now we have the 10 randomized splines that we're looking for. Okay, how can we animate them? This vector noise node comes with an offset, and this is not an offset of an object or a vector. This is the offset of the noise pattern that's being used inside of this vector noise. So if I change this, you can already see that we're getting sort of an animation. We're moving the noise pattern, which changes the value that this vector noise node creates, and that way it looks like we have sparks moving. So, just like in the last video, we're going to use animation time info and plug that into our offset to offset the noise. And when I do that, animation nodes automatically creates a combine vector node, because this is just a single integer. It's that frame here. And we create a new vector that has the frame as an x value, and then 0 and 0 for y and z. And we use that for this offset. And I'm also going to plug it in here, but maybe for the y, just to get a little bit of a different look. Okay, so now when I play the animation, we have sparks flying. They are flying quite wildly though, so what I'm going to do is a number math, take the frame, multiply it by 0.1, just so that our frame animation only moves at 1/10 of the speed. So this looks like sparks flying already. I can go up here and I can go and turn the amount down to 5. Now we have 5 sparks. Okay. But there's one thing I don't like. And that's the ends are also moved around here. Right? So when we look at it from the front, I don't want those ends being moved away from the center here. I want the ends to stay at the end of our original curve that we created. How can we do that? Well, this output here is a list of vectors. And we're randomizing with these nodes here, we're randomizing every single one of those vectors. But I don't want to randomize the first and the last one. And I'm going to add a list slice node. I take this list of vectors. I start at index 0 and at index 1. And this gives me the first control point. This one I don't want to randomize. Okay? I duplicate this, plug the list in here again. I use start index 20 and index 21. This is the last control point, so all the very last control points at the end here. And then I duplicate this again, plug in my vector list, and I start at index 1 and end at index 20. Maybe this has to be 21, 22, we'll see. And I only randomize the control points that are in the middle, that I'm slicing out of this list here with this node. And this is the last one and this is the first one. And now back here, I have to put them back together with a list combine vector list. So the first list that I'm plugging in here is just this list that only contains one vector, which is going to be the first control point. Then the next elements should be these ones, the randomized ones, and then the last one is this one. And now I can plug this in here, and you can see that the beginnings and the ends are sticking sort of to these points, and the rest gets randomized. Over here, this doesn't look correctly. Maybe we have a 20. Let me just go 21. 2021. 22, 23, just okay, and 21. Now it looks correct. So the beginning is stuck to the beginning of our original curve, and the ends are all stuck to the end, and in between we get this randomized, sparky looking splines. That's it for the loop. This is our loop. Now up here where we're executing the loop, something else I'm going to add here is a spline change type node, make it a Bezier curve again, and then a spline smooth Bezier. Of course, this doesn't look like sparks now, but I just want to have a little bit of a smoothing going on here. Just a little bit. Okay. Another thing we can do here is the bevel depth is always 0.06 at the moment. We can take another animation time info and a number random, plug that into the seed. Do something between 0.01 and 0.05. Plug that into the bevel depth. So now when I play the animation, We get even randomized thickness. And we're actually done with our animation nodes. Now all we have to do is make it look interesting. So we go to the shader editor, go to rendered view. I'm hiding my original curve. And on my target object, I'm gonna create a new material, set it to emission, strength to 10. Give it sort of a bluish tint, maybe. Next, I'm just going to create those two Tesla coily things. And that's pretty easy to do. I'm going to create a new UV sphere. Go to edit mode, scale it down. In edit mode, create a cylinder, scale that down. Scale it on the C. G, C, move it down. Select everything, GX, move it over here. Okay. And then I'm just gonna slap a mirror modifier on this. I'm also adding a ground plane. GC, put it down here. And a camera, like over here. I will split this window, go to camera view over here. Okay. Maybe up a little and rotate down, like this. Also extrude this on the C. Control B. W, shade smooth. Now we have a ground plane. We're going to need a material for this. I'll just keep it white for now. Create a material for the Tesla coils. This is going to be very metallic. So what do we look like here in rendered view? Like this. The world should be black. And although this object here, the sparks have an emissive material on them, in Eevee this doesn't really emit light. We're going to need lights in our scene. For now, I'm just gonna add a point light in the middle and turn its energy down. Maybe also tint it blue a little, like this. I'm also going to select my Tesla coils, W, shade smooth. Okay. I'm going to save this. And let's see what it looks like. Okay, this is our animation. Maybe we do want to turn up the bloom effect a little. Oops, wrong slider. Bloom effect. And multiply this by 10 to get more light. And we could call it done. But for my final animation, there's one thing that I added, which has nothing to do with animation nodes, just to give this animation a bit more of a flickering light effect. First of all, I'm going to switch off the shadows on this lamp, because these splines here create these shadows that just don't look right. So I switch off the shadows on my lamp, and I'm going to make the lamp flicker. And the way I can do that is I go to my first frame in the animation, hover over the energy and hit I on the keyboard to insert a keyframe. Now in the graph editor, I can bring up the tools on the right with the N key, add a noise modifier, increase the strength a little, and now when I play this, we have a flickering light. And to make this effect even better, I'm going to duplicate the lamp on the x-axis over here. And here I'm going to shift the offset of my noise pattern for the flickering a little bit. Duplicate it again, shift the noise pattern somewhere else so that they're not flickering at the same time. And now we have this effect. I also need screen space reflections on. And I'm going to make our ground plane a lot darker. Okay, here we go. I think we can call it done. Let me go back to animation nodes, bring up the node tree. So this is the node tree that we created. Just to recap, we create a single target object that contains 5 splines. We could also create 20 splines or 10 splines. We use matrices to create those 10 splines and then pipe those 10 splines through our loop. And this loop takes each spline and randomly moves around the control points that are in the middle, right? So not the first one, not the last one. Only the ones in the middle are getting randomized. They're also getting animated by using the time info frame as the offset for the noise pattern. And we combine everything together into vectors, combine the lists back together and create a new spline out of these vector points. And our loop outputs a list of splines. And then we could put those splines through these nodes and place them into this target object here. And this now contains those 10 splines. And because we're using the frame here for the animation of the noise pattern offset, we get this sort of sparkly looking animation. Now, how do we render this out? Like I said before in the last video, I told you that having this auto execution flag here switched on in animation nodes causes Blender to crash completely after 1 to 5 frames whenever you hit render animation. But there's actually a really easy workaround. The workaround is not to use render animation, but instead go to View and Viewport Render Animation. And what that does is it renders whatever we see here in the viewport into a file, into whatever target output we have set here. But before I do that, let me just show you something. So if I switch to wireframe view and I hit View Viewport Render, I get a rendering of the wireframe. If I go to rendered view in Eevee, and if I have overlays on, and I hit View Viewport Render, I get the rendering with the overlays. So what you want to do here in the viewport is make the viewport look like the final rendering that you want. And that even includes maybe setting the viewport samples to 64. Or if you have a subdivision modifier on something, change the viewport subdivisions to the final subdivisions, because you're rendering the viewport. And now when I hit View Viewport Render, it looks basically the same as if I would have hit Render Image, which works because it's just a single image. It's just that render animation doesn't work. But hitting viewport render animation does work. So that's the little trick that I wanted to show you. That's it, guys. If you like this video, please hit the thumbs up, leave a comment below and subscribe if you aren't already. Also check out all the other videos on my channel. Thank you. See you in the next video. Bye.